Hi, everyone, and welcome to the Tom's Hardware Podcast for April 20th, 2021. We'll just wait a couple seconds for folks to start filtering into our live stream. As always, I'm Tom's Hardware Editor-in-Chief, Avram Pilch, and I am joined by our Associate Editor, Les Pounder. Ash, who is normally with us, is out sick today, but we have some incredible guests. Not just one, not just two, but three guests. We have the geniuses from Gurgle Apps. If you haven't heard of Gurgle Apps, they have an incredible YouTube channel that you can go to where they explain how to use Raspberry Pi Pico and other electronics, regular Raspberry Pi, and you can just learn a ton from them. These folks are really a little younger than us, but they actually know more. So I just want to you guys to introduce yourselves and tell us a little bit about yourselves.
Well, thank you for having us.
Yeah, thank you so much. It really means a lot to be here. I'm Amelie, and this is my brother and sister,
Caleb and Ziva.
Yeah.
Well, I don't know how to start, to be honest.
Well, we love doing the videos on our YouTube channel.
Got so much support lately.
Yeah. And it really does just mean so much to be on the Tom Hardware show. It's really.
Yeah. Well, we started doing stuff like electronics.
Yeah. When we were quite little. We got like our first Raspberry Pi when I got mine when I was about 7. And it was on and off, but apart from that, yeah, we just love electronics, and it's really good fun to do the videos and share our information with you guys.
Yeah. I mean, we've learned so much. My 9-year-old son Isaac, who's been on this show before with us, and I are watching one or two of your videos every day, and we've learned a lot from learning individual projects like your project, which you'll show us later, on how to make a pong game with Pico, to how to use a rotary encoder, and how things like gamma works for adjusting brightness. We've just learned so much from you. These videos are not just tutorials, but you also will get you also learn about the concepts, which I think is great. So how do you decide when it's time to make a new video and what your topic will be?
Well, we just learn on the go, to be honest. So our dad will teach us, or we'll learn something, and we'll just think, let's make a video about that. Or
and then sometimes if we find it hard, we just think other people might find it hard, and we make a video.
Exactly. Like we struggle to pick things up, so we do watch so many videos on tutorials to see how things work, and we think it's just the problems that we come across. We thought we'd share them with other people and how to solve them. So.
And also in the comments we get videos, like we got video ideas, like some guy told us about a reset button, so we did a video about that for the Pico.
So it comes from all places.
That is really fantastic. So how long have you been working with the Pico and RP2040 boards, and what made you decide that those were good boards to work with?
We got them
as soon as they came out. I think the day the Raspberry Pi Pico came out, my brother went to town and got some for us, which was amazing because we live in the UK, so we could get hold of them.
Yeah, and we got them, and then we did like a review on them, and then we're like, oh my god, this is so cool.
They are amazing.
And then when the Tiny came out, it had like more stuff on it, and it was smaller, and it was just. So we've used it since then because it's so good. Like they're smaller than the Arduinos that we were using before, and they're just amazing.
Yeah, they can manage with a lot more than we expected. They always seem to surprise us about how amazing they are, and they're also really fast as well, which is great.
Yep, and I think like anything made by Raspberry Pi, the community is going to be behind it, and so we see a lot of great stuff. Great tutorials, great like yours, great accessories. lots of other RP2040 boards. Have you tried any of the other RP2040 boards besides those two?
Not yet.
Not yet.
Not
No.
yet, no.
I mean, we got sent one, but we've not managed to review that since we've had school and all that. But
Yeah, we got sent a really awesome. It's just it has a Raspberry Pi Pico one, but it's just a board to go with it. Yeah.
Oh wait, is that the Citron?
I think so. Yeah.
yeah.
Les really liked the Citron.
Yeah,
We,
really nice piece of kit.
We tried the Citron. I think our favorite so far is the Feather, because the Feather from Adafruit, because here I have one that's like I've soldered the headers that have both male and female, so you can stack it. But what's nice about these is not only do they have Type C, which is better, and they have 8 megs instead of 2, but they have this compatibility with all of these feather wings that Adafruit makes so many. They have like 24 different feather wings already in the market from their previous feathers. So I have one here that is the Bluetooth and Wi-Fi, and I have another one here that is a joystick, so controller. So it's pretty cool. And now, Les, you've gotten a couple of new ones, right? You have the QT Pi and the Itsy Bitsy.
That's right. Yeah, Adafruit sent them over for review. QT Pi is pretty much the same size as the Tiny 240 from Pimoroni, so the Gurgle Apps team will be very interested in that one.
Yeah.
It's got the added addition of a Stemma QT connection, which is like a proprietary breakout port, so you can plug in these extra boards really easily. So, lovely bit of kit. Avon, would you like me to go through the different connections and boards and that?
Let's talk about a little bit more about Gurgle Apps' latest projects first. So, one of your latest projects is a piano, correct?
Yeah.
Can you tell us about that?
Well, we're thinking, how can we get sound playing on a Raspberry Pi Pico? Because Amelie challenged me to play our theme tune for it.
Yeah.
And I was looking at PWM and all that. And then we thought, let's do a video making our theme tune, just me going from the start of the code to the end. And then from that, I was like, wait a minute. I started thinking, if we get loads of GPI opens,
resistors.
No, GPI opens first.
Oh right, yeah.
And then don't have to explain it really. Get all the GPI opens and have them connected to, connect them to buttons, and then if the buttons got pressed, play a frequency on the speaker. But then there's kind of too many keys on the piano, so we thought, what about resistors? Because Amelie's doing a video about, what was it?
I'd already done a video on voltage dividers,
Mm-hmm.
and we thought, well, why don't we just make a massive a voltage divider, and at each of those, so in between each resistor, if you just take the there'll be a difference in voltage, so a drop in voltage
At each different point of the
of the sort of the string of resistors. So if you can take the voltage from there, then you can detect that and play a certain sound at that
voltage.
Yeah.
So and then we connected. We did that. So we had all the resistors on a breadboard, and I was just touching them with my analog pin and detecting the voltage, printing it on the screen, and then I played the frequency to that, and then we designed the keyboard. I think we started off by 3D printing the design and tracing it, and then cutting them out in stickers and sticking them on, which went really well. Then we did Sharpie. So then we drew the design onto the board, which is a lot quicker. And that turned out well. And then we put it in acid, the copper clay, would it be?
Yeah.
Or copper board. And it etched away the shapes of each of the keys.
And then that's just a metal bit that you can connect to those certain points.
So the
in the string of resistors.
The resistor would connect to one key, and then when you press it, because it's metal, it's connected to the resistor. So
that'll be a certain note. So you can sort of make
Very cool.
So do you have one handy to show?
We do, yeah. So do you want to show?
Well,
I can bring it over.
This is the first ever one that we made. Bring the camera over.
So
This is the
it's
it's mirrored.
You can bring it over then. So this is the first keyboard that we made. It's other way.
Wow.
First.
So does it play just from touching it, or you have to touch it with a specific object?
This one isn't powered, but we play it by touching it with analog pin. Just bring it.
There. So if you want to
Just touch the notes.
Oh, that's really cool. So depending on
If we turn it around, you can see the back.
and that's the resistors.
They're all resistors just
connected. And if you turn it to the other side, you can just see the notes and you can play. It's all tuned like a piano.
That's very cool.
We would normally play a song, but because of copyright, we can't. But...
yeah.
Okay.
Oh wow, that is amazing.
Yeah.
So can I ask you all, how difficult was it to make your own circuit board?
Well, it was kind of difficult because we decided to use to etch it onto the board, so it was quite difficult. We had to get the acids, and now we got our parents to get us the acids. So we used ferric chloride to etch away the copper, and then we just protected it with either like some stickers. In the end, we went with Sharpie because that worked pretty well, and we heard that it worked.
You can see it on my first design. If I just unplug it, so I can bring it up to the camera.
So after we'd done that,
on my first design, you can see like the notes are not even and everything because we didn't expect this to actually work. We just made it test it out because.
Yeah, so these are all the stickers, and then we have a few little testers of Sharpie, and that worked really well. And the one we've just shown you is all done by Sharpie. So, so the Sharpie protects the copper. We use ferric chloride to etch away the copper, and then my brother had they were tinning it with some solder, lead-free solder. Somewhere. I don't think it's.
This is the tinning it with lead-free solder.
But in the end, we just got some solution with some tin solution, but then we used thiourea to actually make the tin and the copper bond.
So chemically tinned.
So it's chemically tinned.
More like my hand copper-free tin.
So of course the acids are kind of quite dangerous, but
definitely, yeah.
Wow. So how long have you guys been working with chemicals?
Well, we've worked.
We've not worked with many dangerous chemicals in the past. This is the first time we've done proper.
We normally breadboard, sticking this stuff in, prototyping.
And before, I remember when I was younger, we did use the same method, just to etch some form of the same sort of thing, but it was just a circuit board. I can't remember for what project.
I think we're doing a fidget spinner a little.
Lighting up fidget spinner.
Don't know if that's gone now.
But that was with our parents helping us and everything, because we were quite young. But yeah.
Wow, that's amazing. So we have a question from the audience. Tim asks, I'm just starting with Pi 0W. Pico is on the list. Would Pico be a positive or negative in learning Pi? What do you think?
I would say definitely a positive because it's like the Pi except it's smaller and it's not a computer. Or it's not like the Pi actually.
It is a computer.
No, it isn't. It's a microcontroller.
Yeah.
But it's nice for getting started, so you don't have to like set up all the computers to just get straight into programming. And wiring up is like quite open, so you don't even have to solder on it. You could just like stick the wires onto the little holes on the side.
It's really good if you're doing electronic projects and you're just going to get right in there.
If you want to just do programming, not messing around with users, passwords, and everything. So I would say it's a positive.
What do you think, Les?
I completely agree with my learning colleagues. It's a fantastic little board. I mean, £4, £4 for the UK people, or £3.60 it is now. it's a cheap board to experiment with, but you've got this wealth of support that's already there. So you've got Raspberry Pi documentation done by Alistair Allen and his team. You've got all the tutorials that are available. You've got the books, the magazines, everything that explains how to use the Pico to build great projects. And I do like the Gurgle Apps team's idea for that piano, using voltage dividers and the ADC pin. Very clever. I never thought of that. Well done.
Wow,
So it's brilliant. A $4 machine, a piezo buzzer, ADC, and a bit of voltage. You've got a piano. Fantastic.
yeah, that is amazing. And I know you have another amazing project that you have video on, which is your Pico ping pong game. Can you show us that?
Yeah. So do you want to? I'll take the camera over, and you guys can play it. Okay. You just sit down there.
It's very competitive, so
Yeah.
This one.
Yeah. So
you can
You
see
can
just
play that side.
if I just bring this over.
it's okay. You can play, and I'll try get.
Let's move the keyboard.
Sorry. Okay. You come over the other side, and I'll try get this on.
Oh God, gosh. Oh. Okay.
1 sec. I'm not in.
Have you
There
got
you
it?
go. I've got it.
So we just got a button to start it again, and
One for that side.
we've got these.
Is it? Can you see that? Okay.
That's it.
Yep, we can see it.
And you can see that it's very light speed. I'm twisting it.
So this is a 2-player game.
Yeah. It originated from a 1-player just bouncing off the other side. Because I think Amelie wanted it to show for her. Is it a potentiometer video?
Rotary encoder video.
Yeah.
Yes.
I'm quite rubbish at this game. She wanted it as an example for using the rotary controller as the control, but the rotary encoder wasn't good and it just didn't really detect it as fast. Like I can just spin this going really fast and and you can see it goes really fast. But with the rotary encoder, it just wouldn't. It was lying. Just wait for my song to finish.
Wow.
That's fantastic.
Yes, I'm old enough to have paid like $100 for a game that could just do that. For a console that could only do that.
Ditto.
That's amazing. My son and I watched your video on that. We're still going through the code which you have on GitHub to try and figure out how you did all the drawing, so we can try and make our own version. We're hoping to make one that's like that's like the Atari Breakout game where you hit the ball up against the bricks. That is super cool. Really amazing. And as you show in your videos, only it's using an SSD 1306 screen, which is just like a really simple OLED screen, which you can buy for a few quid, right? And then you get a couple potentiometers, a buzzer, and but what I love the most about that is the 3D printed stand.
Yeah, we try to make our projects like as accessible and as cheap as possible. That's why we love the Pico, because it's really cheap. £3-4 is really good, and the OLED screens are cheap as well. But we thought we'd go a bit extra on the stand.
Yeah.
3D print it.
We have another question. I'm not sure if I'm qualified to answer, but maybe not quite a Pi question. What VR, AR, XR technology are we excited about? Have you guys seen any VR, AR stuff that lately that really excited you?
Not lately, no. I mean, not really. We're more just. I don't know how to explain it. We're just more.
We quite like. What we've got at the moment, we think is really cool, like the simple projects that like anyone can do.
Yeah. So we've not really.
We've not seen anything yet that's interested us.
But we'll look into that probably.
Yeah. I think you actually had a great video where you showed the AR app from Adafruit.
Oh, I forgot. Yeah.
That you point at. That you can. That's a really great use of AR, right? Where you download this app and then you can point it right at your Pico, and it will show you in augmented reality the pinout, which is great. I need to have that built into my glasses because that is my biggest beef with the Pico, is that it doesn't have the pin names on the top, whereas some of the third-party boards do have that. So like that's a great use of AR, where like I think AR is great when it becomes practical like that. And people will certainly be able to. I mean, I don't think any of the Pis or Picos are powerful enough to power VR, but they certainly are powerful enough now to do machine learning, which I think is the next frontier. So speaking of things you can connect to your Pico or to an RP2040 board, Les, you were going to show us the different connectors, the different connector options that folks have, because this is kind of important. This is kind of important if you're getting something, if you're in the market for an RP2040 board and you're thinking, hey, maybe I want to connect a sensor to it, right?
Oh, definitely, yeah. So Raspberry Pi Pico, it's aimed at beginners, and Raspberry Pi is in general aimed at beginners. And one of the biggest problems you have when you start with electronics is wiring. Now, as the Gurgle Apps team can confess here, wiring up your projects can become quite messy, and the breadboard will be full of wires, and you won't know where things are, which wire is broken, why isn't that working. And it's another thing to debug when you're first learning electronics and to build stuff with Raspberry Pi Pico. So there are solutions out there to help you to get it working. So I've been testing a few of them. So I've got them on my desk right now. I'm going to go to the overhead camera. Hope it's going to work this week. There we go. Lovely. So I've got slap bang in the center. I have Raspberry Pi Pico with Siege Studio's Grove Shield. Now, Grove is a type of connection, 4 pins, and it can be either analog input, PWM, so pulse width modulation. It can be I2C as well, if I remember correctly. And it uses these little breakout boards to connect up common components. So right now, I've got a passive infrared sensor here. I've got a motor breakout board here, and I've got a standard little fan motor here. And they're connected to the Grove breakout board. It tells me on these little sections here what pins they're connected to, so pin 18, pin 19, that sort of thing. And I don't need to worry about messing around with wiring on a breadboard. I just plug it all together like Lego, just stick it all together, and it will work. So I've got a quick demo running now. So when I put my hand over the PIR sensor, it's going to cause the fan to turn on. I'm going to turn it on, the switch. It takes about 3 seconds to load. If I wave my hand across it, it turns on. And you can see the fan going around. If I do it again, it takes about 6 seconds to go around each time. But it's so easy just to put these things together rather than having a breadboard full of wires.
Someone asks if it's easy in the UK to get the Grove Shield because they've been trying to get it and they can't find it.
Yeah, they contacted me on Twitter about this a while back. I only know that it's available from Seed at the moment. Obviously, for the UK, there's going to be some import costs and quite a high delivery price. But surely one of the resellers, such as Pimoroni or the Pi Hut, is going to pick up on this, or even Amazon perhaps one day. I'm just not sure when that's going to be, sorry. So Grove is not the only connection that you can have. Just set the fan off again. I forgot it's on. There we go. There's another type of connection called Stemma. Now, Stemma is from Adafruit. And again, it's a 3 or a 4 pin connection. And Stemma are these black connections here. I just tilt it that way. You can see it. There you go. You've got 4 pins and 3 pins. The 3 pins are digital I/O. The 4 pins are I2C. This is a Pi portal, by the way, from Adafruit. It's connected to. These have boards that just plug straight in, and you can build lots of cool projects. Now, I haven't got any Stemma boards to show you, but I have got a smaller version called Stemma QT. So Stemma QT is, seriously, it's just Stemma shrunk down. So rather than a 2mm pin pitch, it's now a 1mm pin pitch. And I've got it connected to this QT Pi RP2040 just here. So that's the one I've just reviewed. The review went out at the weekend. Lovely board. And I've got it wired up to this Stemma QT board. This is an MPR 121. And that doesn't mean much to anyone. What it really is a capacitive touch sensor. So right now, it's putting a little bit of voltage through these two bananas. That's why there's bananas on my desk. And if I press a banana, you'll see the light change on the board. That's a neopixel. So let's just bring it up a little bit. So I can go red to green. So it's measuring the voltage across me. Basically, I'm an input. It's seeing all the water inside the banana and me and using it as a capacitive touch. And it's all done by this lovely little Stemma QT connection between the two. There's no wiring involved, just that thing. But Stemma QT isn't the only connection. We've also got Qwiik, which is from SparkFun. So Qwiik is exactly the same as Stemma QT. Uses the same boards and same connections. So here is the SparkFun Micro RP2040. And I've got it wired up to a light sensor. Now for this one, I'm going to switch over to another screen. And right now it's reading the light level. So that little sensor there is a LTR 390 and it's reading the light level from my overhead light. So if I turn the light off now, you should see it drops considerably. So it's a 12 right now. And put it on, 800 and something. And again, simple little project. If you just want to measure light or plug in a temperature sensor or a motor controller or something like that, you can plug this straight in. No messing around with breadboards or anything. Just plug straight in, secure it into the project, and away you go. And all these connections are new to me. I've for years been doing breadboarding and plugging things in the old-fashioned and hard way. But with these new boards, I'm really interested to learn more about what you can do. They're great.
So I'm curious, Gurgle Apps team, how if you had advice for parents or kids, like at what age would you say it was good to get them to get started with a breadboard, to use breadboards and electronic components that way?
I would say as young as possible, really. Like as soon as they're interested, maybe. I mean, it could be as young as 5, but it could be because you could lighting an LED to them might be really exciting. But then also, yeah, any age really, I'd say is a good age to get involved.
We started lighting stuff up at, I don't know,
using breadboards.
7, 8.
Yeah,
We were
so
lighting up stuff and we got really excited.
yeah, Ziva was 5. She was quite young. It's always been around the house. And
Yeah. I mean, that's my experience too with my son, is that we started because I was interested in it. I was like, hey, I'm gonna get you doing it. So I think the first like computer that he had was when we built a Kano, like the Kano computer, which uses a Raspberry Pi 3, when he was like 5, almost 6, and yeah. So at what age would you say it's good to get into different kinds of programming? Looks like you guys program a lot in Python. What programming languages would you say are the best for kids getting started and then advancing as they get older?
I would say Python for starting because it's
we started in Python.
it's kind of, it's like you're telling it to do something. Like print kind of to me means show it, like print it out, and time.sleep, it just means, I mean,
I think with other programming languages, I think for example C, you've got to do a lot, and it can get you've got to give it a lot of values and everything. So then when you go with Python, you can be very simple and you can just mess around and hack and stuff. And I think it's quite compatible with a lot of other electronic devices and everything. So yeah, I mean, we started with Python. So
did you ever use a block-based language?
At school, we used Scratch, I think.
Yeah,
which I was already learning Python at that stage though. But
I think
Scratch. What I did in Scratch is I kind of like when you can view the page source, but it was a kind of scratchy type thing. Scratch.
It was Scratch.
It was, but I could see it in Python. I can't remember how I did it, but when everyone else was like moving the blocks, and I was like coding the Python. So when they're like say hello, I'm going print hello.
I think with our dad, he tried to when we got involved when we were really young, both me and my brother, he tried to stay clear of the block sort of programming, like Scratch and everything. He was like, only Vi for you guys, like VIN.
Yeah, I'm with your dad. My son started, if your child can't read yet, then obviously a text-based language is a challenge.
Yeah.
The best one I've seen for really young kids, for those listening, is the Lego Boost system, because that is completely, there's no writing on it. So if you have a child who hasn't learned to read and write yet, like that's a decent programming experience. But once a child learns to read or write, I'm totally agree with your dad. In fact, when I see my son using certain block-based languages, I'm like, oh, you're too old for that now. He's really into lately Make Code Arcade, which is like Microsoft's block-based language where you can easily make your own video games with it. And though you can see it in JavaScript, it's really made to use in blocks. So he keeps doing that. Don't you want to use Pygame instead? Make a game in that. So I think it's really critical to Python is a great first language for kids getting started. Oh, we have to ask you the question we ask all of our guests except for the ones who work for Raspberry Pi, because it's not fair. How many Raspberry Pis would you say you have in your house?
Right.
Yeah.
Depends if you're counting the dead ones.
The deceased.
Sure, the dead ones and the Picos.
Oh.
Altogether 12,
More than 12.
14, I don't know.
About
We had a few.
She had
11. We are probably about between
this is
10
Ziva's
and
Pi,
15.
which broke, and she had a funeral for it.
Yeah, we had a few.
Oh, I'm sorry to hear that.
Yeah, but she got a massive upgrade. She got a Raspberry Pi 400 as an upgrade for that.
Oh, hey.
Very nice.
You can't. That's hard to beat. How did you kill it?
We actually don't.
We don't know. So
Yeah.
she's
We
really
tried
good. She treats it really well. It's got its own like little surface and everything. And
The cat might have come on the desk or something.
yeah, maybe the cat might have had something to do with it. We're not sure.
Aha. The cat did it. Yeah, I have one here that broke for some reason, and I keep it around so I can hand it to my daughter, because she's 2 and she likes to wander around with stuff. So, yeah, sure, you want this? No problem. Yeah, I think I probably have like something like 12, or if you count zeros, I probably have like, I don't know, 16, 17 regular Pis, and now I must have like 10 different RP2040 boards. Less, you've got like 40 Raspberry Pis or something at this point.
Something like that, yeah. And the Pico mound is growing. I think I've got another 4 in the past week from different vendors to look at.
Yeah, it's just amazing, because every time you get a different board, different add-on board, you want to plug it in and different project and not take it out of the whole thing. That's for sure. Well, I want to thank the Gurgle Apps team so much. They're for not only for joining us this week, but for just being an inspiration and on the web, inspiration to everybody in the community, to me and my son watching your videos. Folks can check. What's the best place to check you out? To check out your videos?
Probably our YouTube channel.
Probably just YouTube channel.
What? YouTube.com/GurgleApps.
Yeah. Also, thank you so much for having us.
So much.
It just means so much to have. Yeah, because you guys are like inspiration for us as well. So
Great. Well, thanks. I hope you find some useful stuff on our website, as we have found from your videos. And thanks to everybody for listening and watching. As always, you can catch us here at 7:30 p.m. GMT, 2:30 p.m. Eastern Time on Tuesdays. And we will see you next week. Bye, everyone.
Bye.